Hello friend, welcome to my channel. Today I'll be talking about correlation coefficients. So let's get started. Okay, so I guess on a single variable observation you can find out the mean and standard deviation of the sample. If not, let's briefly remind you. Say if you have a sample of size n, say x1, x2 up to xn. So this is a sample of size n you have. Then the mean is defined as, mean of that sample is defined as x bar equals to 1 by n times summation of xi I equals to 1 to n. Pretty simple, average of all those sample xi you have. So this is nothing but the average. Okay, this is nothing but the average. Okay, now I am going to define what do you mean by standard deviation of that sample. So standard deviation is notation is denoted by Sx, where Sx square is given by 1 by n times summation xi, small xi minus x bar whole square. Okay, so this is nothing but the measure of deviation from the mean. This is nothing but the measure of deviation from the mean. Okay, so this is all about the single variable, that is one variable function, one variable you have. Okay, now if you have two variables, say x and y, okay, so you have an observation of two variables. Okay, so how that, so you have a bivariate observation, say x and y, this is a bivariate observation. So how this thing look like? Let's have an example in our hand. Say we have a data of 5 students, their heights and weights are measured. Okay, so the data is look like that: height, weight. So height in feet and this is weight in kg. Okay, this is the student, say student number. Student number 1 have 5 feet height and weight 45 kg, whereas student number 2 have weight 6 feet and weight 60 kg. Student number 3 has height 7 feet and weight 65 kg. Okay, student number 4 has 5 feet height, 48 and so on, 5.5 feet and 50 kg. So see, this is a bivariate data. You have two set of observation, height and corresponding weight. So this is a bivariate observation. Okay, now what do I mean by a correlation coefficient? So correlation coefficient is nothing but the association between these two observation. X and y. So this correlation coefficient is nothing but the association between them, x and y. So what do I mean by the association? The association between x and y is nothing but the, if what do I mean by the association is nothing but if height increases whether weight is increases or not, or in the other way around, if height decreases then weight is increases or not. So we want to measure an association between them, whether the change in one variable has an effect in change in other variable. What are the effect? Is the effective positive, or say change in one variable is changing, increasing in change in other variables? So is there any positive correlation, or is there any negative correlation, or at all is there any correlation? So let's see. So what is the measurement of that correlation coefficient? This is given by R, and the formula is summation of xi minus x bar you have into yi minus y bar. Okay, so you know you have xi, you have y bar, you have yi, you know how to calculate x bar. X bar is nothing but the mean, and the formula is given by, I have already given, the formula is given by this one. This is the formula for mean. So you know how to calculate x bar and how to calculate y bar, and the range is from 1 to n. We have total n number of samples. So this is by n sx into sy. So you know how to calculate standard deviation. So sx square formula you know, so you know that formula even. So you can find out this r. Okay, one can write down this thing as I equals to 1 to n, nothing but capital Xi. Remember, this one is small xi, this one is capital Xi into capital Yi by n sx into sy, where capital Xi is nothing but xi minus x bar, and capital yi is nothing but yi minus y bar. So this is R. Okay, now our conclusion will be now this is our conclusion. So conclusion will be Act 1, if r greater than 0, we will be telling that x and y are positively correlated. Okay, if r is less than 0, we will be telling that x and y are negatively correlated. Okay, and if r equals to 0, then x and y are uncorrelated. That is, there is no correlation between them. So there is no correlation between x and y. So this is our conclusion. If r equals to 0, we will be telling x and y are uncorrelated. Okay, so what do I mean by positively correlated? Means, I have already said, let me clear, x increases imply y is increases. Similarly, x increases for negatively correlation, x increases implies y decrease. Okay, so this is negative correlation. Now what do I mean by uncorrelated? So there is no relation between them, that is no association between x and y. So I guess this is a bit clear to you, that is if r greater than 0, x and y are positively correlated, that is if x increases implies y increases. If r less than 0, that is x and y are negatively correlated, that is if x increases y decreases. And if r equals to 0, that is there is no association between them. Okay, let's understand this thing via geometry, that is say geometric understanding of this fact. So how to do that? The idea is pretty simple. draw one variable in x-axis and other variable in y-axis. Okay, so we have x data and y data. So this is, so I am drawing x variable in x-axis and y variable in y-axis. You can do in another way. So the point is, just draw one variable in x-axis and another variable in y-axis. Okay, and plot all the pair of points x and y. So this is all the pair of points you have. Okay, so plot all the pair of points you have. So this is all the pair of points x and y. Okay, so all the points are x and y. Okay, now what I'll be doing, say, and the mean of this random variable example is, say here x bar, say, and here the mean is, say, y bar. So what I'll be doing next, I'll shift, and this origin is 0 0. Okay, and this origin is 0 0, and what I'll be doing, I'll translate this origin 0 0 towards the origin x bar y bar. So I'll basically shift the origin of this graph. So what I'll be doing, the same plot, but now the origin is x bar y bar. So how to translate it? You can just pull this, this x-axis in this direction, you can pull down y-axis in that direction. So in that way we can just translate the origin towards x bar y bar. Okay, now what are the formula to give the translation? So what are the translation we have used? The translation is xi minus x bar and yi equals to small yi minus y bar. So these are the translation we have used to shift the origin 0 0 towards x bar y bar. Now I'll be plotting all xi and yi. So these are all the points we have. Okay, and now this is the first quadrant, this is second quadrant, this is third quadrant, this is fourth quadrant. And you know, in first quadrant x and y, this is x, this is y. In first quadrant x and y are both positive, so x and y greater than 0. So in that quadrant x into y is less than 0. In that quadrant x and y are both negative, so x into y is again greater than 0, because in that quadrant x is negative, y is positive. So in second quadrant x into y is less than 0. In third quadrant x into y is greater than 0. In fourth quadrant x into y is less than 0. Now the formula, I'll remind you the formula of R. The formula was summation of xi yi into n sx sy. I is from 1 to n. This is the formula for measuring R, the correlation coefficients. Okay, now if you see, now what we will be doing, we will take the summation, we will calculate this summation xy for all xy, that is we will multiply x into y for all those points and sum over all those points for all xy. And if this summation is greater than 0, of course that will imply that R is greater than 0. Okay, and of course I forgot to say that R is equals to this one whenever sx and sy is non-zero, then only R is defined. I forgot to say, just this is a very important crucial thing, I forgot to say that R is defined only when sx and sy is non-zero. Generally standard deviations are greater or equals to 0. So it is defined only when sx and sy is not equals to 0. Okay, now so what we are doing, we are summing all the points x and y, and if that sum is greater than 0, then R greater than 0. So this implies positive correlation, we have already seen. Okay, this implies positive correlation. So see, if that summation of xi is greater than 0, so and R is greater than 0, so we can say that most of the points are lying in the first or third quadrant. Otherwise this is not possible to have summation of xy is greater than 0. you're getting, because otherwise, because this one are negative, so to make the whole thing positive, I am summing over all xy. So to make the whole thing positive, I have to have most of the points in first and the third quadrant. In the other way around, if x into y for all xy is less than 0, we have r less than 0, we have negative correlation. So trend is first and third quadrant, and here the trend will be negative correlation, and the trend will be second and fourth quadrant. And if x into y for all xy is equals to 0, that is r equals to 0, that is uncorrelated, then the points are distributed evenly in all quadrants. Okay, so this is all about the geometry. So you can see, so for the negative correlation, the picture will be something like that. The picture will be something, so this picture is nothing but the positive correlation. So this is r greater than 0. You can see that the trend in the points are mostly in the first and third quadrant. So of course summation of xy will be greater than 0 for that particular figure. So here r will be greater than 0, and in this picture, say all the point, the most of the trend will be in the second and the fourth quadrant. So this is x-axis, this is y-axis. So this is r is in that picture, r will be less than 0 because all the points are in the second and the fourth quadrant. So for uncorrelated and r equals to 0, the point will be evenly distributed. So this is the point, and the point will be evenly distributed. Okay, so this is all the points are evenly distributed. Okay, so I guess you have understood, you have a idea how to calculate r and what are the geometry behind that. Okay, so thank you once, and I hope you enjoy my lecture. If so, don't forget to comment. Feel free to comment if you have any doubts regarding that, if I made any mistakes even. Okay, anyway, thank you.